There's antimony, arsenic, aluminum, selenium, and hydrogen and oxygen and nitrogen and rhenium, and nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, uranium, europium, zirconium, lutetium, vanadium, and lanthanum, and osmium, and astatine, and radium, and gold, and protactinium, and indium, and gallium, and iodine, and thorium, and thulium, and thallium. There's yttrium, ytterbium, actinium, rubidium, and boron, gadolinium, niobium, iridium, and strontium, and silicon, and silver, and samarium, and bismuth, bromine, lithium, beryllium, and barium. Isn't that interesting? I hope you're all paying attention. There's going to be a short quiz later on. There's holmium and helium and hafnium and erbium and phosphorus and francium and fluorine and terbium and manganese and mercury, molybdenum and magnesium, dysprosium and scandium and cerium and cesium and lead, praseodymium and platinum, plutonium, palladium, promethium, potassium, polonium and tantalum, technetium, titanium, tellurium and cadmium and calcium and chromium and curium. There's sulfur, californium, and fermium, berkelium, and also mendelevium, einsteinium, nobelium, and argon, krypton, neon, red, and zinc, and rhodium, and chlorine, carbon, cobalt, copper, tungsten, tin, and sodium. These are the only ones of which the news has come to Harvard. And there may be many others, but they haven't been discovered.
Hello, everybody.
We're putting a grating in front of the video camera, and you can see the slit right here.
But we can't see it.
Of a compact fluorescent tube, and the grating spreads the light out into the various colors. Watch, it's hot.
It's white, too. That's a hot. White.
Okay. Now we're going to have to stop this at some point because it only goes in. So I'm putting the thing in and out.
Okay, are you going to explain it?
So what's happening is the light gets dispersed by the grating into its component colors, and those colors are due to atomic emission in the fluorescent tube. Okay.
Okay. So thank you for watching the presentation of fluorescent lights.
Okay, everybody, we're demonstrating fluorescence, and I'm using a UV light, and you can see my socks and shoelaces are very fluorescent. I have here is it showing up good?
Yeah.
A ball called a Vaseline glass marble, and it has uranium oxide in it, a form of uranium. You can see how it glows. But when I turn the light off, you can see it goes off instantly. It doesn't show an afterglow. Now I also have, this is not as dramatic, a fluorite crystal, all right? And you can see that glows as well. Now here comes the big one. Let's see, do I still have it in my pocket? I have a ruby. A ruby. There's the ruby. Look at that. Can you see the beautiful color? And finally, I have, well, not finally, but, well, I can't find that. But so let's go on to this. This is a dye. Can you see that? That's a dye called fluorescence, and that gives a beautiful fluorescent color. And this one is a dye called rhodamine B, and that gives kind of a reddish orange color. And finally, I have chlorophyll from a plant that I extracted from a plant. It's actually green, but when I shine the UV light on it, it gives a red glow. So those are some examples of fluorescence. Now, with the E equals MC squared that we showed you.
That isn't on there anymore.
There's an afterglow. It's called phosphorescence. And it lingers. Even the fluorescence lingers, but it lingers only for about a billionth of a second, a nanosecond. But this lingers for tens of seconds. It slowly decays in intensity. So those are some examples of fluorescence. Thank you for your attention, and we'll talk to you later. Okay, everybody, I have two crystals here. One is a ruby, that's that one, and one is a sapphire. And you can see they're both giving off a red glow. The ruby is a little redder, but they're both giving off a red glow. The ruby and sapphire both are aluminum oxide, but the ruby has chromium oxide, the sapphire has iron oxide. What is the reason why they both give off red color? Well, if my grandson turns the light on, you can see that the ruby is red on the right and the sapphire is blue on the left. But the sapphire must have a little bit of chromium oxide like the ruby to give off that red color. The iron oxide doesn't fluoresce. Okay, so that's the